All right, so let's go ahead. Let's take a look at our last video. So here we are just going to go right into it, full-blown interval notation, domain and range of different functions, okay? Now, for this first one, we do see that this is a function, this V-shaped figure, because it does pass the vertical line test once, so we can go ahead and say that this is a function. Even if something is not a function, like what we're going to talk about in the second example, we can still find the domain and range for that value. Okay, so first thing to point out is that our graph starts here at -4, 4. And as we go down and to the right, we then increase and we land here at 4, 4. So because we have this open circle, let's just kind of review what we know already. We would say that the domain as an inequality is starting where x is 4 or -4 and ending where x is +4. And because of this open circle, -4 is less than x. And because of this closed circle, -4 is less than x, which is less than or equal to 4. So now on the flip side, because of interval notation, because of this less than symbol, we would use a parenthesis, -4. We would use a bracket and plug in +4. Okay. Now range is very, very similar, except remember in range, we read from bottom up. So it looks like we're starting here at 0. Okay. Because 0 has this closed circle, 0 is less than or equal to y. And as we head up, notice both of our highest y values are 4. Now, this one has an open circle, meaning you can't actually have y as 4 over here. But because this is a closed circle, you can. So we would still use the less than or equal to again and put that +4. Now, if they had both been open circles, then no, that would have not been okay, and we would have had to use just the less than sign. So our interval notation would be 0, 4. Okay, let's take a look at the next one. If we use the vertical line test, notice it crosses the function in 2 spots. So this is actually not a function. Okay, we know that this parabola has no ending in sight. There's just, we can't really see it, but there are arrows on both ends. Okay. So when we read domain from left to right, it looks like we're starting here at 0. Because the line actually crosses through 0, we can include it, okay, like an open circle. And it looks like it's heading to positive infinity, right? Now remember, in inequalities, we would never use the infinity. So we would simply say that x is greater than or equal to 0. But in interval notation, we would say bracket 0, infinity. And remember, with infinity, we always use that open parenthesis. Now, because your range, as we read bottom up, has those arrows, it's going to get taller and 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 taller. So really, our range is all real numbers, which we could use the symbol, or in interval notation, it is just -infinity to +infinity. Okay. Now, I know on this next figure, it kind of looks like the line has arrows. It does, in fact, if you're confused or if you're not quite sure, it does have arrows on both ends. And this does pass the vertical line test at different points. So we do know that this is a function. Okay. Now, our domain, because we're heading from left to right and there's arrows, our domain is all real numbers. So in interval notation, we would say -infinity to +infinity. And our range, it looks like right here, it stays pretty constant. And right here, it stays pretty constant. So that is where y is -2 and where y is 3. So we would say -2 is less than or equal to y, which is less than or equal to 3. And we do use the less than or equal to signs because it is a solid line. Like you can actually plot those points along the line. And then if we, in terms of interval notation, we would say -2 with a bracket, 3 with a bracket on the other end. So that wraps up our interval notation today with the videos. Please go ahead and grab